Welcome, folks, to our first lesson in energy, work, power, and machines. Okay, so this is a Form 3 topic, topic 4. I'm going to go through it, and hopefully, in 4 or 5 lessons, I'll be through it. So, these are like 4 pieces in one topic. We shall see what is work, we shall see what is energy, we shall see what is power, and what are simple machines. So this is our lesson 1. So before we look at these aspects of this topic, let us look at what are the sources of energy, main sources of energy. After getting that will be introduction part, and then we shall now define what is energy, what is work, what is power, and what are simple machines. So let us look at first, what are the main sources of energy that we have? The energy from layman perspective. Okay, so we have the sun. Okay, this is the main source of energy. Okay, which can produce both heat and light. Sun is our main source of energy, which can produce heat and light. Okay? The second one is wind. Okay? Wind. We can feel the wind, but we cannot see the wind. Wind is mass air in motion. Mass air in motion. And when that mass air that is moving, it possesses energy. Okay? That's why you can see the leaves swing, because there has been energy on the leaves or on the trees. Another source of energy that you know, fuel. Okay? Things like charcoal, things like wood, when burnt, they produce energy. Okay? We are talking of the materials. When burnt, they give you energy. Do you see at home? We have fire, then we put a sufuria of water, and then that water was cold, maybe at 22 degrees centigrade, and after a short while, the temperature rises, showing us there is energy that water has acquired. Wood has given out energy, and that energy has been taken in by water. What can we observe there? Increase in temperature. Another source is geothermal. Okay? Geothermal. This is underground water which is exposed to large amount of heat. Okay? Underground water exposed to large amount of heat, and therefore when there is some crack in the ground, the steam, the heated water underground come out in form of steam. So this is underground water exposed to large amount of internal heat, turning water to steam. Okay? Turning water into steam. And because of the high pressure inside there and low pressure on the surface, the water comes out. It oozes out. It gushes out through those openings. So that is what we call geothermal. Then we have dams. Dams and waterfall. Dams and waterfall. Okay? Dams and waterfall. So here we are talking of the water under this situation, a dam that is raised, okay, possesses stored energy, which can be harnessed to bring about electrical energy, like in hydroelectric power stations, okay, like in a hydroelectric power station. So there are some dams that are raised, okay, then water is controlled to come out of those dams, and when water comes out, it comes out with a very high speed, okay, and that speed is able to rotate the turbines. Then we can talk of electrical energy, okay, that deals with hydroelectric power stations. So dams and waterfall, the bottom line is they possess some energy at a raised level. Water comes out in a controlled way, and we are able to turn the turbines. The turbines are component together with the magnets and other wires bring about electrical energy. So those are akina Kindaruma power stations. That is where you can get that kind of stuff. Then we have ocean. Okay, ocean. Tides, okay, and waves possess energy. Tides and wave possess energy. If you go to Mombasa, to the public beach, you will feel your body being pushed because of the tides and waves. Because of tides and waves, okay? The particle of waveform remains stationary, but remember, energy is passed on, okay? If you see a boat that has been anchored, you will see it trying to swing. It is kind of swinging somewhere because of the waves, because of the tides. They possess energy, okay? So what do we say? Tides and wave possess energy which can be converted to other forms, okay? Which can be converted to other forms. We have nuclear and atomic energy, okay? Nuclear and atomic energy. So matter is made up of particles, you remember that, and then we have atoms, and in each atom there are electrons going around the nucleus, and at the center of the atom we have neutrons and protons. So when we have either a big number of neutron or less number of proton that is not balanced at the center of an atom, then that atom is said to be unstable, and eventually it will break down and releasing radiations and a lot of energy, okay? That one you will do it in form 4 under radioactivity. But in a nutshell, what do we say? The unstable nucleus of an atom can split or be made to split. You will learn that there. It can split spontaneously. But we can also make it split. We can make it break. Just a distant example. You break an egg, then you have whitish and yellowish stuff coming out of that egg. So the nucleus is like that egg, okay? The white stuff and yellow stuff are contained inside the nucleus. The shell can give you a picture of they are contained inside. So if we break the egg, we are able to see, there is stuff that comes out. Now, that is a distant example. The reality is unstable nucleus of some elements will break or can be made to break. When they break, they release radiations and a lot of energy, which we call atomic energy. Okay? That is basically what I have here as the main sources of energy: the sun, the wind, fuel, geothermal, dam and waterfalls, ocean, nuclear or atomic energy. Now, the energy we have, we can categorize into two. There is energy that can be depleted, and there is energy that renews itself. So we can now talk of, let me focus the camera down here a bit. Yes, maybe there. I'm sure you can see very well. We can focus a bit. Yeah. So what I'm talking about here now is renewable. Some of these sources are renewable and some of these sources are not renewable. Okay. So what is the difference between renewable and non-renewable? We are talking about renewable energy is supplied by processes that are inexhaustible. Inexhaustible. Renewable energy is supplied by processes that are inexhaustible. Okay? Non-renewable, on the other hand, this is the kind of energy that is supplied by processes that are exhaustible. Processes that come to an end, get finished, have a stop. Okay? Non-renewable. You cannot recycle. You cannot make it come back again. No. So, a question that you can be asked, list. So these are some of the questions. You can have question on list 2 examples of renewable sources of energy. You can be asked, list 2 examples of sources of non-renewable energy. Okay? So, renewable and non-renewable are specific. I can also twist and tell you, list 2 sources of energy that are inexhaustible or are exhaustible. So you see, I have denied you a recall word, renewable and non-renewable. Instead, I've used some language in definition. So do not cram, but understand that renewable energy is supplied by processes that are inexhaustible. So the key word, inexhaustible. And for non-renewable energy is supplied by processes that are exhaustible. Okay? So you can be asked to list. I can ask you also to distinguish. So in this introduction, before you finish the day, before you retire, ask yourself if you know what are the main sources of energy, what are renewable and non-renewable sources, do I know how to distinguish? Those three parts, or can I say even four, from list, renewable and non-renewable, okay? And then you can be asked to distinguish, then you can be asked to give example. Those are simple things you just read. Tomorrow we shall continue with lesson 2, where we shall be looking at one of the pieces at a time. Remember, this is, I think it's chapter 4, where we do work, energy, power, and machines. And there is a lot of calculation, there is a lot of application. So till then, if you have any request, please use this email, odexrobert, Robert with a double T, at gmail.com. This is the email that you can use for this kind of work. So I've just given you a rough picture as an introduction of what we expect. Tomorrow we shall go, or rather the next lesson, we shall go through one piece at a time. We can start with the work, then go to energy, go to power, and then there is a lot on simple machines. Thank you very much. See you